Naming organic compounds, specifically aliphatic compounds. The increasingly large number of organic compounds identified with each passing day, together with the fact that many of these compounds are isomers of other compounds, requires that a systematic nomenclature system be developed. Just as each distinct compound has a unique molecular structure, which can be designated by a structural formula, each compound must be given a characteristic and unique name. The IUPAC systematic approach to nomenclature. The IUPAC nomenclature system is a set of logical rules devised and used by organic chemists to circumvent problems caused by arbitrary nomenclature. Knowing these rules and given a structural formula, one should be able to create a unique name for every distinct compound. Likewise, given an IUPAC name, one should be able to write a structural formula. In general, an IUPAC name will have three essential features. 1. A root or base indicating a major chain or ring of carbon atoms found in the molecular structure. 2. A suffix or other element designating functional groups that may be present in a compound. And 3. Names of substituent groups other than hydrogen that complete the molecular structure. In order to name organic compounds, you must first memorize a few basic names. These names are listed within the discussion of naming alkanes. In general, the base part of the name reflects the number of carbons in what you have assigned to be the parent chain. The suffix of the name reflects the type of functional group present on the parent chain. Other groups which are attached to the parent chain are called substituents. Alkanes, the saturated hydrocarbons. Hydrocarbons having no double or triple bond functional groups are classified as alkanes or cycloalkanes, depending on whether the carbon atoms of the molecule are arranged only in chains or also in rings. Although these hydrocarbons have no functional groups, they constitute the framework on which functional groups are located in other classes of compounds, and provide an ideal starting point for studying and naming organic compounds. These are the examples of alkanes. The first column provides number of carbons, while the second column provides the name of each alkane. 1 carbon, methane. 2 carbons, ethane. 3 carbons, propane. 4 carbons, butane. 5 carbons, pentane. 6 carbons, hexane. 7 carbons, heptane. 8 carbons, octane. 9 carbons, nonane. 10 carbons, decane. 11 carbons, andecane. And 12 carbons, dodecane. These are the examples of simple unbranched alkanes, showing the difference between the molecular formula and structural formula and the isomers of each alkane. The names of the substituents formed by the removal of one hydrogen from the end of the chain is obtained by changing the suffix ane to yl. Note that the ane suffix is replaced by yl in naming groups. The symbol R is used to designate a generic or unspecified alkyl group. For example, methane to methyl, ethane to ethyl, and propane to propyl. IUPAC rules for alkane nomenclature. 1. Find and name the longest continuous carbon chain. 2. Identify and name groups attached to this chain. 3. Number the chain consecutively, starting at the end nearest a substituent group. 4. Designate the location of each substituent group by an appropriate number and name. And 5. Assemble the name, listing groups in alphabetical order using the full name. Example given, cyclopropyl before isobutyl. And reminders, the prefixes di, tri, tetra, and the likes used to designate several groups of the same kind are not considered when alphabetizing. There are a few common branch substituents which you should memorize: isopropyl, sec-butyl, tert-butyl, and isobutyl. In summary, the name of the compound is written out with the substituents in alphabetical order, followed by the base name, derived from the number of carbons in the parent chain. Commas are used between numbers, and dashes are used between letters and numbers. There are no spaces in the name. These are some of the examples of alkane and their respective name. First example, 4-ethyl-2-methylhexane, 4-ethyl 3,3-dimethylheptane, 2,3,5-trimethyl 4-propylheptane, methyl-cyclopropane, 5-sec-butyl 2,7-dimethylnonane, and 3-ethyl 4-methylhexane. The alkyl halides. The halogen is treated as a substituent on an alkene chain. The halo substituent is considered of equal rank with an alkyl substituent in the numbering of the parent chain. The halogens are represented as follows: F, fluoro, Cl, chloro, Br, bromo, I, iodo. Here are some examples: 3-chloro-2-methylpentane, 2-bromo-3-methylbutane. Cycloalkanes. Cycloalkanes have one or more rings of carbon atoms. The simplest examples of this class consist of a single unsubstituted carbon ring, and these form a homologous series similar to the unbranched alkanes. The IUPAC names of the first 5 members of this series are given in the following table. Substituted cycloalkanes are named in a fashion very similar to that used for naming branched alkanes. The chief difference in the rules and procedures occurs in the numbering system. Since all the carbons of a ring are equivalent, the numbering starts at a substituted ring atom. These are some of the examples of simple cycloalkanes: cyclopropane, cyclobutane, cyclopentane, cyclohexane, and cycloheptane. It also shows the difference between molecular formula, structural formula, line formula of simple cycloalkanes. IUPAC rules for cycloalkane nomenclature. 1. For a monosubstituted cycloalkane, the ring supplies the root name and the substituent group is named as usual. A location number is unnecessary. 2. If the alkyl substituent is large and or complex, the ring may be named as a substituent group on an alkane. 3. If 2 different substituents are present on the ring, they are listed in alphabetical order, and the first cited substituent is assigned to carbon number 1. The numbering of ring carbons then continues in a direction, clockwise or counterclockwise, that affords the second substituent the lower possible location number. 4. If several substituents are present on the ring, they are listed in alphabetical order. Location numbers are assigned to the substituents so that one of them is at carbon number 1, and the other locations have the lowest possible numbers, counting in either a clockwise or counterclockwise direction. And number 5, the name is assembled, listing groups in alphabetical order and giving each group a location number. The prefixes di, tri, tetra, and the likes used to designate several groups of the same kind are not considered when alphabetizing. Alkenes and alkynes, the unsaturated hydrocarbons. Alkenes and alkynes are hydrocarbons which respectively have carbon-carbon double bond and carbon-carbon triple bond functional groups. The molecular formulas of these unsaturated hydrocarbons reflect the multiple bonding of the functional groups. This table shows the difference between the saturated hydrocarbons alkane and unsaturated hydrocarbons alkene and alkyne. Double bonds in hydrocarbons are indicated by replacing the suffix ane with ene. If there is more than one double bond, the suffix is expanded to include a prefix that indicates the number of double bonds present. For example, a diene and a triene. Triple bonds are named in a similar way using the suffix yne. The position of the multiple bond within the parent chain is indicated by placing the number of the first carbon of the multiple bond directly in front of the base name. These are some of the examples of unsaturated hydrocarbons, alkene and alkyne. 1,4-hexadiene, 1,3-hexadiene-5-ine, 3-pentene-Y-ine, 5,5-dimethyl-1-hexene, 3,4-dipropyl 1,3-hexadiene-5-ine, 1,4,4-trimethyl-cyclobutene. IUPAC rules for alkene and cycloalkene nomenclature. 1. The ene suffix indicates an alkene or cycloalkene. 2. The longest chain chosen for the root name must include both carbon atoms of the double bond. 3. The root chain must be numbered from the end nearest a double bond carbon atom. If the double bond is in the center of the chain, the nearest substituents rule is used to determine the end where numbering starts. 4. The smaller of the two numbers designating the carbon atoms of the double bond is used as the double bond locator. If more than one double bond is present, the compound is named as diene, triene, or equivalent prefix indicating the number of double bonds, and each double bond is assigned a locator number. And 5. In cycloalkenes, the double bond carbons are assigned ring locations number 1 and number 2. Which of the two is number 1 may be determined by the nearest substituent rule. IUPAC rules for alkyne nomenclature. 1. The yne suffix indicates an alkyne or cycloalkyne. 2. The longest chain chosen for the root name must include both carbon atoms of the triple bond. 3. The root chain must be numbered from the end nearest a triple bond carbon atom. If the triple bond is in the center of the chain, the nearest substituent rule is used to determine the end where numbering starts. Number 4. The smaller of the two numbers designating the carbon atoms of the triple bond is used as the triple bond locator. 5. If several multiple bonds are present, each must be assigned a locator number. Double bonds precede triple bonds in the IUPAC name, but the chain is numbered from the end nearest a multiple bond, regardless of its nature. And last, number 6, because the triple bond is linear, it can only be accommodated in rings larger than 10 carbons. In simple cycloalkynes, the triple bond carbons are assigned ring locations number 1 and number 2. Which of the two is number 1 may be determined by the nearest substituent rule.